The idea that certain things, events, or people can cause other things to happen plays a huge role in human life. We constantly desire to know why things happen in science, love, sports, philosophy, and so on. But because the underlying laws of physics don't care about the direction of time, cause and effect don't have the same meaning at a fundamental level. It's not that anything goes. The basic constituents of the universe, the particles and forces of modern physics, behave in predictable ways according to the laws of nature. In principle, you can just as easily know their past paths as their future ones. The current momentum and position of a particle determine its movement forward into the next second, but they also determine how it was moving in the previous second. Neither is really a cause preceding an effect. There's just a pattern that particles follow. Kind of like how the integer after 42 is 43, and the integer before it is 41. But 42 doesn't cause 41 or 43. There's just a pattern traced out by those numbers. At a fundamental microscopic level, all we can say is that there are patterns between events. The macroscopic human-scale concepts of cause and effect only emerge when you have larger collections of particles like humans. As we know, time does have a direction for larger scale systems, and we can indeed talk about a spark causing oxygen and hydrogen to turn into water and an explosion. Spark plus oxygen plus hydrogen, and then water plus explosion, is a sequence the universe follows, and it only happens in one direction. You never see a reverse explosion where water spontaneously splits into oxygen and hydrogen gas, and then at the very end emits a little spark. One way of thinking about causes is that the tiny spark has great leverage over the future. If you hadn't lit the spark, we wouldn't have seen a giant explosion. It doesn't work the other way. Removing or changing a tiny part of the giant explosion doesn't imply that there wasn't a preceding spark. When a small change to the present implies a big change to the future, the small thing we're changing is generally thought of as a cause. Leverage can also go the other way. Take this new pencil. The wood it's made of contains trace amounts of radioactive carbon-14 created by nuclear bomb testing. If the pencil didn't contain that carbon-14, that would imply that no nuclear bombs had been detonated in the last 80 years. While if you removed a pencil-sized amount of one of the atomic bombs, this pencil would still be basically the same. In this case, the fact that the pencil has lots of carbon-14 means that it has a lot of leverage over the past. Instead of calling the carbon-14 in the pencil a cause of the earlier detonation of hundreds of nuclear bombs, we call it a record of the bombs. In general, when a small change to the present would imply a big change to the past, the small thing we're changing is thought of as a record or a memory. So the distinctions between cause and effect, records and predictions, aren't fundamental to underlying physics. They only really make sense on the large scale because of the direction of time.